Assalamu alaikum dear students. Now today we are going to discuss second portion of this unit, that is quadratic equations. You know that the general form of the quadratic equation is ax square plus bx plus c, where a, b and c are the real constants. Also you studied in class 10th that any value of x, here x is variable, any value of x which satisfies this equation is called its root. Now it has at most two roots because its degree is 2, and there are a number of methods to solve this quadratic equation, that is to find the roots of this quadratic equation. You know those methods. Now here this quadratic equation, that is ax square plus bx plus c, has two roots and it represents the two parabolas. Now either a upwarded parabola, that is this u-shaped parabola, or a downwarded parabola, that is inverted u. Inverted, either it represents this or this. That is the graph of this equation ax square plus bx plus c equals to 0. There are two types of the curves which are represented by this quadratic equation. One the upwarded parabola and second one the downwarded parabola. You also know that the discriminant of this equation, that is ax square plus bx plus c, is denoted by d, and its value is b square minus 4ac. Now there are three conditions. Either d is greater than 0, that is discriminant is greater than 0, and discriminant equals to 0, and discriminant less than 0. Now in first two cases, that is discriminant greater than 0 or equals to 0, then the quadratic equation has one or two roots, one or two different roots. Now when discriminant is greater than 0, then which implies that its roots, that is quadratic equation, has two different roots. This means that the graph, that is this parabola, touches the x-axis at two different points. That is here for upwarded parabola. For upwarded parabola we have x1 and x2, they are different points, and this graph, that is parabola, touches or crosses the x-axis at two different points, that is x1 and x2. Here this x1 and x2, these are called as the roots of this equation when discriminant is greater than 0. This means that these are the real distinct roots. Now for similarly for downwarded parabola, that is inverted u, this graph, again when discriminant is greater than 0, that is d is greater than 0, the graph or this equation has two roots, means that the graph crosses the x-axis or touches the x-axis at two different points. Here x1 and x2 is are two different points. Now we will consider the second case when a discriminant equals to 0. When discriminant equals to 0, this means that the given equation has one root or two equal roots. Simply we can say that it has only one root, because quadratic equation in a real set has at most two roots. Now firstly we considered this when it has two different roots. Now we will consider when it has only one root, means discriminant equals to 0, that is b square minus 4ac equals to 0. It has one root. This means that the graph touches the x-axis at only one point. That is for upwarded parabola, the graph is like this, it touches at x equals to x1, while as for downwarded parabola, it touches the x-axis at suppose x equals to x1. So this is the case when roots exists. Now when discriminant equals to less than 0, when discriminant is less than 0, you know that the given quadratic equation has no root, that is roots does not exist. But roots does not exist in a real number system. In a real number system, you studied earlier, you studied, or the first portion of this unit is dealing with the complex numbers. Now when discriminant is less than 0, while solving we have root d, that is root of b square minus 4ac. Here this root d d is negative, which implies that when we have the square root of negative number, it is simply iota d, iota root d. Means that this equation, that is quadratic equation ax square plus bx plus c equals to 0 when b square minus 4ac is less than 0, means that there exists two complex roots, or we can say that in a real system roots does not exist, so it has complex roots. Now suppose that one of the complex root of this quadratic equation, suppose given quadratic equation a plus iota b, a plus iota b, now it is one root, one complex, purely complex number, it is one root. You know that it is represented by the point AB, point AB in a plane. So suppose that both A and B are positive, this means that here we have this point. Now from this point draw two perpendicular lines on x and y axis through this point, that is this and this. You also know that the given quadratic equation either represents upward parabola or downward parabola, which implies that the graph of this quadratic equation, when it represents the upward parabola and discriminant is less than 0, then its graph is like this. So this means that this point, that is point x equals to a plus iota b, is on here, through which we have to draw, or we can draw two perpendicular lines. So this is considered as the root of this quadratic equation whose discriminant is less than 0, that is it has complex root. Now similarly, when it represents the downward parabola, or suppose this point AB lies in fourth quadrant, suppose both A and this B is negative, A is positive, and we assume that this point is represents, or this point represents the complex number a plus iota b, a plus iota b, and the given quadratic equation represents the downward parabola, then its graph is this. It never touches the x-axis, it only touches the this point, that is this complex number, where we draw two perpendicular, mutually perpendicular axes. Now here this point is considered as a root of this quadratic equation. Root means where it touches the x-axis, where it touches the x-axis. So here in real this does not touch this x-axis, while it touches these two new axes. That is why this is called as a root, and we say that its roots does not exist in the real set, because its graph never touches the x-axis, it never touches the x-axis. So this was all about the complex number, this complex numbers and quadratic equation. Inshallah in tomorrow's video lecture we will discuss new unit. So thank you.